Hey guys, welcome back to AlgoYogi. We are now doing stack series, and our next medium level stack problem is car fleet. Let's go to LeetCode and give it a read. There are n cars at given miles away from the starting mile 0, traveling to reach mile target. You are also given two integers, position and speed, both of length n, where position and speed at the ith index represents the position of the car and the speed of the car, the ith car. A car cannot pass another car, but it can patch up and then travel next to it at the same speed of the slower car. Right, so slower car would be in the front, and there is a car, if there is a car coming from behind which is like way faster, but if it reaches the slower car, then they're both gonna go at the same speed of the car that was in the front right from the beginning. Okay, a car fleet is a car or cars together driving next to each other. The speed of the car fleet is minimum speed of any of the car fleet. Makes sense? If a car catches up to a car fleet at the mile target, it also will be considered as part of the car fleet, and at the end we are returning number of car fleets to arrive at the destination. These are our inputs. So let's understand what's going on. We are here given targets. Let's say if this is my position line, if this is my position line, this is my position line here. So there are these cars are basically, these are different cars which have position, speed. They're sitting somewhere at a given time, like at the given, let's say we are taking a snapshot of this race, but all of them started at position 0. The target is 12. Let's say this is 12. This is 12. Now these are different positions. So here, let's say it's 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. Okay. Now these different cars will be placed somewhere here. So let's say on position, the first car is on position 10. So this particular car is right here. Then car at position 8 is right here. Then 0, but position 0, this is right here. I don't know why this one didn't start moving. Then at position 5 is the car right here, and then 3 is over here. Now I think it would be better if we draw all of these cars together and then also place them on this race track, you can call. So what I'll do is I'm gonna basically get rid of all of this. I'll keep the target, and let's place all of that data right here. So these are different cars that we have, and I'm gonna place them on our track. So this is my track. Now let's say if this was 0 and this is I guess I'll draw a little closer so that we can see it clearly, and this is 12. Now my 10, this particular car, and I'm sorting these. So this is not given to me as like sorted by position. All of these arrays that are given to us is just random snapshot of these mixed up cars and position, and they have their speed and then they have their position. That's what is given to us. So what we will do is, like, for our convenience to calculate the fleet, we're gonna sort these by position so that we can see all the cars, what is their position and what is their speed, so that we're gonna start calculating these fleets from the front of our track. Let's say if all of these cars are running this way, then we will start calculating all the fleets from the front, so that we know if we find a car that was going maybe like slower or something, then any car that comes from behind, basically with a faster speed, it has to stop and go with the slower speed of that car and make fleet, right? So let's do that. So what will happen is, okay, so I'm gonna place all of these cars right here. So this one goes like in the front right over here. Then next car will be this right here. Next car will be basically position 5 here. I'm gonna basically like make them a little smaller. Okay, so I should have done this like earlier, but you know what, we're gonna learn. Okay, all right, 3 right here, 5 right here. Then we have our 8 is gonna be right here, smaller. And then our last car, and I've sorted them. I'm sorting them like right here. All right, these are our cars. We can append little wheels into them if you want, but this is the position of our car right now. So if you see, this is my target is 12. My target is 12 right here. So what I'll see is I need to calculate the time for each of these cars to reach my target, right? And then based on that time, I will go from, because in this position, if you see, the track is really small. Any car that comes from behind has to stop and go with the slower speed, right? And in the final moment when they are all finishing, we need to basically check how many fleets arrived at the destination. So what I'll do is I'll have a stack that will basically collect all the fleets. So let's say I have my stack right here, and I start checking from the back of the track and seeing all these cars. So first car that I see is 10, 12, right? It's going with the speed of 2, and then its position is like right now 10. So what I'll do is I'll calculate its time to reach 12. So to calculate time, it will be time is equals to distance by speed. So what is the distance that this car needs to travel to reach 12? That is target is 12 minus current position 10 divided by speed 2. So basically it will be taking just 1. You can say like time unit 1 could be hour or like minute or whatsoever, but it will be taking 1 unit of time. So I'll push that on top of my stack, right? So that's done for this first car. Now I'll check the time for basically this car. So this is the current state. Like I'm checking this right here is the current state. These cars are all lined up to finish at position 12. Now they all have different speeds. They all have different position. Now based on the time, we will know that what will be basically I would say like the time they are going to take right now from this position to reach 12. All right, so we have done for the last car, which was on position 10. Now I know it's taking time 1. So at the end I can decide that whatever car took that amount of time, if there was a car that was taking greater time than 1 unit of time, that means it has to stop. Basically, if it was taking greater time, then it's gonna come behind this car. It's gonna come right behind my car at position 10 and just stop right here, and then they're both gonna finish at the same time, making just 1 fleet. All right, so let's check for the car at position 8. Its time would be, distance would be 12 minus 8 divided by 4, which is 4 by 4. So that means it's either equal. So this is equal. Basically 4 by 4 is 1. 1 is equal to this right here. So that means I should not append this car to my stack. its time to my stack, because at the end I'll be returning the length of the stack, and that will be the final number of fleets that will be finishing at position 12. So I will not be appending it. Because at the end they are both reaching in the same time, finishing at the destination at the same time. So it was told to us that either it has to be greater or equal. If the time calculated is greater or equal to the top of the stack, that means they both are going to make a fleet and then finish at the same time. So we are not going to append that to our stack. Let's go check for the next car coming with like speed of 1 so fast to our destination. So here let's calculate the time. This is the current car we are checking. So time would be 12 minus 5 divided by 1. That will be 7 by 1. It will be taking the time 7 unit of time. So what I'll do is, this is basically my top of my stack is not greater than or equal to this. So that means it will arrive after 7 minutes, like, or maybe 6 minutes or 6 unit of time. So what I'll do is I'll place this right on top, and the top of my stack is now 7. Okay, this car is done. So let's go to the next car. How much time this is going to take? This will be taking 12 minus 3 divided by, so this is distance, remaining distance, difference or whatever, and then the current position, because it needs to travel this much distance right now, because it was already at the position 3. So 12 minus 3 divided by 3, that will be 9 divided by 3 is 3. So it will be taking 3 unit of time. But if you remember, the top of my stack 7 is greater than or equal to 3. So what does that mean? This car basically will come and make a fleet with this car, because this is going really slow. This car is going really slow, so this will come and make fleet with this car and they will finish together, right? So what will happen is, now we will not append this to my I will not append 3 to my stack, because now I can go by just this fleet in the front, which is right here, this fleet. Oh my god, this fleet right here, that can just represent both of these fleets together. All right, at the end I will be returning the length of my stack. Okay, so final car going with the speed of 1 at 0th position. How much time is that going to take? It will be basically, time will be, distance is 12 minus 0, so it has to travel all the way. I don't know why this car just remained at position and all the cars are right, like you know, at least they travel some distance, and this one, the green one, going really fast. So 12 divided by 1, it's gonna take 12 unit of and then that means this 12, the top of my stack is not greater than or equals to basically 12. So I will append 12 right here. Okay, 12 right here, because this car will arrive really late, right? This car will arrive really late. So what I was checking for my stack to append these to my stack is either the stack is either not stack, either there is nothing in the stack, or stack stop is basically smaller. Is basically smaller, greater than or equals to my current time. If these conditions match, that means I will be appending, it's not greater, actually it's smaller. That means the time is smaller, so they have arrived, you know, it's smaller. If this time is smaller, they have already gone and reach the destination, and my time is just like way bigger. So I'm taking this particular car is taking some time, so I will append it, stack.append, append the time. Okay, append the time. So this will take big of n time complexity, that will be our solution, and big of n space complexity solution. Now we have understood really well what will be our approach. First thing first, we will be combining our position speed and then sorting them and just like in a reverse order, so that we are basically going from the car that is on like the closest position, right? The closest position. Okay. Looks good. So let's make all the cars together. Right now we have the position and speed. So let's do some. It's called list comprehension list, something like that. So first thing, let's have position I, and speed I. That's what we did, right? Speed I. For I in range, length of anything, speed or position, whatever. So let's say speed, because they're same they're same length, by the way. So now let's sort our cars. Cars.sort and how we are sorting in the reverse order. By the way, if this sort function should take by default it takes the first position to as a relative item to compare when it's sorting. Reversed equals true. All right, reversed equal to true. You don't have to write this. You can just, when we are going for a car, so for car in cars, we could have just reversed all those cars here like this. You didn't have to write this reverse, okay? But like right now, this is all reversed. Now we're good to go. So for this car to reach the target, let's calculate the time. So time would be target position minus its current position. What is its current position? It's at the 0th index. Current position for this car divided by the speed. What is the speed? Car at first index. This is the speed. This is the second element. Now this time, what I'll do is if and I forgot to create this stack. At the end, stack is what we are going to return the length of the stack. So return length of the stack. That this will tell us how many fleets will arrive at the destination. So if there is nothing in the stack, let's say if not stack, if there is nothing in the stack, this condition should pass, like it will create a circuit, short circuit, and this will append. So we will append the time to my stack. Okay, time to my stack, or the time that I'm seeing right now is greater than the top of my stack. So stack on the top. If this time is greater, that means what? That means the time this particular car is gonna arrive is gonna be way more than, or it's greater than, not even equal, greater than the time that's sitting on the top of the stack. So that means the top of the stack car has already arrived, and this is like in the way. So that means we have to append this time on the stack, on our track, so that we know how many cars are coming behind it, because this will create its own fleet. This is its own fleet, right? I think this makes sense. We have understood that on the conceptual part really well. Okay, otherwise you do nothing basically, and only we are appending it if either stack is empty, you are your own fleet, there is nothing in the way, or the time that you are going to arrive at the destination is bigger than the car that's on the stack, the time that I have appended. All right, so let's zoom out and test it. Otherwise, what must have happened is like the time that calculated, if it is not in this these boundaries, that means I don't have to append it. That means that time was smaller than the top of my stack. That means this car cannot pass. It has to join the fleet because the car on the top of the stack was going slower. Okay, so we don't have to append it. Any car that comes faster than that has a time that is lesser than the top of the stack, that will have to keep appending from the back. So zoomed out, let's run it on our examples. Something, what is it? Invalid argument, because it's not sort but sorted. Is it like that? Okay, this should be the go. Awesome. Pa. Woohoo! Okay, let's write the time complexity, which is going to be, I think in the conceptual part I said big of n, but because we are sorting, so it's going to be big of log n log n. Space would be whatever we talked about. So sorry about the conceptual part, I'm not gonna re-record, but complexity. But this is where we talk about the time complexity once we have written the solution, and this particular thing is making it big of n log n. Otherwise, space is same. There could be, these cars are going at the same speed and they were or at the different position, but they will never meet. So that means we will have at the end the same number of cars which were initially. So they are at different position, they will arrive at the different time if the speed was same for all of the cars. All right, let's go back to AlgoYogi, mark this all. See you guys later. Weather is awesome and I'm gonna go enjoy it now.